Let's learn about function operations. You need to get ready by grabbing paper and pencil, take some notes, and do some problems along the way. We're going to be looking at adding, subtracting, multiplying, and dividing functions. We'll talk about when you have to restrict the domain, and then a new thing called function composition. With function operations, it's really getting used to the notation. So when we have f plus x, that's not a multiplication. That does not mean multiplication. It means f of x plus g of x. F minus g of x is f of x minus g of x. This one is multiplication, so you will see it either way. You'll see any of these either way. F of g times x, f of x times g of x. And then the last one, we can use the fraction to show division. So this is showing division. You have to remember that when g of x is in the denominator, g of x cannot equal 0. Here we're given f of x is x squared minus 3 and g of x is 2x minus 5. And we're asked to do f of x plus g of x. So I'm going to substitute f of x in, and I'm going to add it to g of x. Notice I'm using parentheses. I don't necessarily need it here, but I just want to show you. And then I'm going to simplify by combining like terms. And that is my final answer. In example 2, we're going to look at subtracting f of x and g of x. F of x minus g of x. This time we definitely need the parentheses because we have to make sure we're going to distribute that negative to both. So we get x squared minus 3 minus 2x minus 5. Simplify to x squared minus 2x minus 8. Now we're going to multiply f of x times g of x. I need parentheses, x squared minus 3 times 2x plus 5, and I'm going to do a big distributive. So the x squared will get multiplied to both. We'll have 2x cubed plus 5x squared. The negative 3 is also going to get multiplied to both, minus 6x minus 15. You should check to see if anything needs to be combining like terms, but we are all set, and that is my final answer. Here we have division. So f of x goes in the numerator, x squared minus 3, over my denominator, 2x plus 5. Please keep in mind we can't cancel the x's. There are different terms here, not factors, so we can't cancel anything. And it feels like we might be done, and that is the simplified version, but we now have to remember to look at our denominator because we don't want it to be 0. So I'm going to set 2x plus 5 equal to 0. 2x equals negative 5, x equals negative 5 halves. But I want to write that as cannot be because I don't want to get that plugged in for x and make my denominator 0. That is my restriction to the domain. You have to keep that in mind with division. Here we have f of 3. So we actually have a number value that we're going to be plugging into the x and every x that would be in the equation. So it's a substitution, and I'm going to substitute it in. So f of 3 is going to be 3 squared minus 3. F of 3 is 9 minus 3. So f of 3 becomes 6. This is function composition. With function composition, we have f of g of x. It's read with the word of, and you just read it left to right. It basically means you're substituting g of x into f of x at each x, and you're replacing the x, so the x isn't there anymore. So you start on the innermost, and you replace into the outside one. Another way of writing it is with this open circle. And that's not a multiplication sign. It's read f of g of x. And that means composition. So you have to be familiar with both notations. Some people call the second one fog, because that's kind of what it looks like, and that is an abbreviation. Here's a little joke. Darn, I can't see through this fog. So here we have f of x, g of x, and we're going to do the composition of f of g of x. So again, I want to start in the inside and plug g of x into f of x. That means I'm taking this full group, 2x plus 5, I'm plugging it into the x, then I'm going to square it, and don't forget the minus 3. If there's a number at the end, that's often forgotten. So f of g of x is, I'm going to take my g and write it and plug in parentheses, square it, minus 3. And now we have to simplify. So I'm going to write out 2 sets of parentheses to show that I'm going to be multiplying. And I'm going to do my big distributive again. And I will simplify that up as 4x squared minus 10, plus 10 plus 10. So plus 20x plus 25 minus 3. One more step, 4x squared plus 20x plus 22 would be the composition of f of g of x. Notice when I plugged it in, back up here, I don't have an extra x. When you plug it in, you don't have that. You replace this x with the whole grouping. Let's try a different order, g of f of x. So now I'm going to take f, plug it into g. So I'm going to take this group and I'm going to plug it into there with parentheses. So g of f of x is 2, open parentheses, plug my f in, x squared minus 3. Don't forget that plus 5 at the end. And let's simplify. 2x squared minus 6 plus 5 is 2x squared minus 1. We could plug some numbers in. We could have f of g of 2. And you could do this a couple ways. You could start by just plugging g into f and getting the expression, or you could plug the number in. I'm going to start with the number, so I'm going to plug 2 into g, and then whatever I get there, I'm going to plug that into f. And I'll show you how it works the other way as well. So I'm going to start with g of 2. That means I'm plugging 2 in for my x, and g of 2 equals 9. So now I'm going to do f of 9. And I'm going to plug that in, and I get 9 squared minus 3. So f of 9 is 78. So let's remember that, 78. When I did it earlier, I got this. When I did out the x, I got this once I simplified. So now if we take the 2 and we plug it into each x, let's make sure we get the same answer. So 4 times 2 squared plus 2 times 20 times 2 plus 22 is 16 plus 40 plus 22, which is in fact 78 as well. So either way, but I personally think plugging the 2 into g makes it a little bit easier. Here's a challenge. We have a of b of c of d. It looks a little scary, but just remember to start on the innermost and work your way out. So here I give you a, b, c, and d of x. We're starting with 3. So I'm going to do it the first way that I showed you. I'm just going to plug the 3 into d. So let's see what d of 3 is. 4 times 3 plus 2. d of 3 is 14. And then I'm going to do c of 14. So that becomes 5 times 14 minus 6, and that is 64. And then I'm going to do b of 64, which is negative 3 times 64 minus 4, which is negative 196. And finally, a of negative 196 is 2 times negative 196 plus 1 for a lovely answer of negative 391. Just to recap, and this should get into your notes, get used to seeing it both ways, addition like this or addition like this separated. Don't forget to restrict whenever you have your division. There's not usually too much you can do there. Maybe you can factor and then simplify, but it's more important to include that restriction. And then we have this new thing at the end, which is our composition. You will see both ways, and it's read as f of g of x and abbreviated FOG. Good job.